Yeah, definitely. Someone did not write, right? And it's you. You did not write. You just like rushed into the next video. Hey, you guys, ne? So how many, stuff do we have? We've got one, two, and three, right? We've got three of them, so we need three space. Guys, I'm tired. I'm gonna draw it as it is. I'm not a princess. Okay, so what is R? So R actually stands for ratio. So in fact, let me just do this. Um, let me just do this. So I'm just gonna take this. So just like try to copy it, right? And I'm just gonna take it right here. So now, what is this? So this is gonna be of SO2. This is just gonna be of O2, and it's just gonna be of SO3, right? So what is the ratio of SO2? As you can see, just going to be 2. Yeah, it is. What is the ratio of O2? It's 1, because like there's no one here. It's 1. And then what is the ratio of SO3? It's just going to be 2, right? So I'm just gonna come here and I'm just gonna write this 2. So now I want to fill everything in terms of, in terms of these rice tables. I just don't want to fill everything in terms of the rice table. So how on earth are you going to do this? So the best way is you go back to where you were interpreting your diagram, right? You go back to where you're interpreting your diagram. Remember, I means initial. So what did we have initially? So if we look at SO2, initially, we've got 8 mole of SO2, right? So you're just gonna come here and write 8. We've got 8 mole of SO2. What about O2? You realize that initially, we've got 10 mole of O2. So I'm just gonna come here and just write 10. But like, what about the products, which is SO3? Initially, we've got 0 product. It makes sense, right? We've got nothing. So I'm just gonna write 0. So now, what about change? What about change? So let's just forget change for now. Let's just focus on filling up this amazing diagram, right? So how do we fill it? So just gonna go and say, okay, at equilibrium, do you see it? At equilibrium, which one is equilibrium? This is equilibrium. At equilibrium, we've got 6 mole of SO3. So at equilibrium, we've got 6 mole of SO3. So I'm just gonna write 6. So now, let's just focus on change, right? So change means this, guys. I wanna show you something. Change means, until change is here, right? Change means, what must I, okay. In fact, let me just show you something, right? Before I actually go any further. Let me just show you something, right? When we start, right? When we start, we started with what? We started with what? We started with reactants, right? And then what are we ending with? We end with products, right? We end with products. Now I want to tell you something, guys. I want to tell you something. This is really important. On a chemical reaction, right? On any chemical reaction, right? Reactants decreases and products increase as the reaction proceed or something. So reactants will decrease and the products will increase as the reaction proceeds. So I want to show you something. Let's say that you are cooking your pap. As you cook your pap, what do you realize? You realize that, hey, my maize is running out. That is why each and every single month you buy 80 kg of maize. It is because it is your reactants. And during a chemical reaction, your reactants are going to decrease. So what is the change that is happening on the reactants? The change that's happening on the reactants is a reduction. It is decreasing. So when we come here, we know that SO2 and O2 are our reactants. So we know that they are going to decrease. I'm just going to write a minus. This means minus right there. They're going to decrease. But what about our products? our products increase. I mean, like when you are cooking your pap again, you start with 0 pap. But at the end of the reaction, you are having pap all over the... So it means that the product increased. Does it make sense? So your product is actually going to increase, right? So that is actually important. So your product actually increase. So your reactants, they decrease. But your products is going to increase. So in other words, what must SO3 increase with such that on equilibrium we've got 6? So in another words, we want to say 0 plus equals to 6. 0 plus, let me just write it like this, right? 0 plus equals to 6. 0 plus, and then we have nothing, equals to 6. So what is that? So 0 plus what? What is our Our is 6, right? So 0 plus 6 actually equals to 6, isn't it? So in other words, it actually means that here, our answer is going to be 6. So now you want to use your stoichiometry, right? To fill in the change for SO3 and O2. So how are you going to do that? So let's say you want to find the change of what? Of O2. So if you want to find the change of O2, this is O2, right? You want to use, at this point, because that's what you have the change. Like you want to focus on everything that's on the change. You only focus on the digits on change. You use the digits on change, right? So now, what do you have? You have got SO3, right? You want to say that, okay, at SO3, I've got 6. Do you see it? On change, on SO3, I've got 6. So it means that I'm just going to say 6 multiplied by. What is the ratio at O2? So the ratio at O2 is what? Is 1. Do you see it? You multiply this thing by 1. Divide by. You divide by the ratio at what? At SO3. Do you see it? You divide by the ratio at SO3. And the ratio at SO3 is what? Is 2. So it means that here you're just going to divide by 2. So the change is just going to be 6 multiplied by 1 over 2 is 3. So this is 3. So now, I want to show you something. By the way, you can use any, guys, right? Like, you can use any, you can use this, you can use this, you can use any, right? I want to show you something. I want to find the change of SO2 using what? Using SO3, which is 6, and then I'm going to use another one, trying to find the change of O2, trying to find the change of SO2 using 3. Now, I know I'm confusing you, but I'm going to explain. So now, since I found the change of O2, now let's actually try to find the change here. What are we going to do? So guys, my point is you don't have to use 6 all the time. You can use any number, right? So now, let's actually use this one, which is 3. So we want to find the change, right? We want to find the change of SO2, right? So we want to find the change of SO2. What do we want to do? We want to say that, okay, I want to use O2. In this example, I want to use O2, right? So if I use O2, what is the change on O2? It's 3, right? So I'm just going to say 3 multiply by. So you multiply by the ratio of where you are going. So the ratio of where you are going, I'm going to SO2. So the ratio there is 2, right? So I'm just going to multiply by what? By 2 divided by. Now, you want to divide by the ratio of what? Of where you are from. So I'm from what? O2, because I've used 3, as you can see. So the ratio of O2 is just 1. So now, here you're just going to have 1. So this becomes what? 6, because 3 multiplied by 2 is 6. You're just going to have 6, right? So that's how you do it. That's how you do it. You can play around with these things, eh? You can play around it. So what is 8 minus 6? So 8 minus 6 is 2. What is 10 What is 10 minus 3? So 10 minus 3 is going to be 7. So now you want to find your concentration, isn't it? So how can you find your concentration? So to find your concentration, you want to use the formula for concentration, and you're going to find this on your answer book. The formula for concentration is C equals to N divided by V. This is concentration, right? This is your mole, and this is your volume, right? So we want to find the concentration. So let's say we want to find the concentration of SO3. What is the number of mole? It's 6. Just gonna say 6, and you divide it by the volume, and the volume is 1/2. So you're just gonna have like 1/2. So as you can see, it is 6 divided by 1/2, right? So what is 6 divided by 1/2? I think it's just gonna be 12. So even here, what is 7 divided by 1/2? It's 14. Even here, what is 2 divided by 1/2 is just going to be 4, right? So now you want to calculate your Kc. So what is your Kc, right? So your Kc becomes what? Concentration of the product to the raise of the coefficient divided by concentration of the reactant raised to the coefficient. So what is our Kc at this point? So our Kc is the concentration of SO3 raised to the power of 2. This is our product, right? And we're just going to divide this by the concentration of SO2. So the concentration of SO2 raised to the power of 2 multiplied by concentration of O2 raised to the power of 1. So what is my Kc? So what is the concentration of SO3? So the concentration of SO3, as you can see, is just 12, right? So I'm just going to come here, and we say this is just going to be 12, and we square it. Divided by, what is the concentration of SO2? So the concentration of SO2 is just going to be a 4. So I'm just going to come here, and I'm just going to say 4, and I'm just going to square it. Multiply by the concentration of O2 is just 14. So you hit this on your calculator, and you just find the Kc for this problem.